Hello everyone, this is a video lecture for pre-calculus. We're doing 5.8 applications, so that means word problems. There's going to be a lot of decimals flying around. We are going to be using our calculator. Now, I'm looking at my questions ahead, and there's actually a lot of really cool questions, but then some of them are kind of meh. We'll just do our best, and again, just think calculator. Calculator required for like all of this stuff. So 5, 8, 1. You can't get any simpler than that, right? So they have a triangle here for us, and I have an A, I have a B, and then I have a C, and then I have a little b, and then I have a little a, and they say that capital A is equal to 31.8 degrees, and little b is equal to 47. And they say, hey, what's capital B equal to in degrees? What's little a equal to? What's little c equal to? The good old days. So it'll only get complicated from here. Not this problem. I'm saying like in other sections. So what we need to do is learn one tiny little rule that is super important to us. It's called the 180 rule. The 180 rule. And what happens, that's just 180 dash rule, by the way. What happens is that your A plus your B plus your C for any triangle all add up to 180. Well, this is C, and I put a little, I don't know, a little hat on him or a little feather in his cap. So he's a capital. He's a capital instead of a lowercase. That way you can just tell the difference. Anyways, so I'm wanting to add up my my three angles, and I should get 180. So my A is a 31.8. Awesome. My B is unknown. My C, looking right there, is 90. It's one of those right angle things. Is equal to 180. So you could skip ahead and just basically said, well, move the 90 over, you got 90, so then these two other guys must be equal to 90. And that's fine. So move everything else over, and B is equal to 90 minus the 31.8, which in my calculator got a 58.2. And there you go. Cool. Now that I have all the angles, you can go and use like sine, cosine, and tangent to be able to figure out the other things. So I got B, and I need to find A and C. So I have this one, and I want to find an A. Which one should I use, sine, cosine, or tangent? Tangent, very good. So tangent is probably the best option, and tangent of A, which we already have an A, so that's kind of nice, is equal to A over B. Well, my B, of course, is a 47. Solve for A. I'm going to move that over. So A is equal to 47. There we go. Tangent of 31.8. Calculator. And I got 29.14. To find C, you can use like sine or cosine. I used cosine. You can also do Pythagorean theorem if you want. And so you can say that we got the 29.14 squared plus our 47 squared, square root it, 55.3019. Again, there's a lot of ways. You can use the cosine, is fine. I have a little note here. It says it's best to use the numbers given so that you aren't rounding. So I would have frowned on my answer here for C. I would have said, no, boo, you shouldn't use that. Sad face. But in the end, you'll probably still be fine. Just don't round and then round and round. Just, use as many decimal places as you can. But there you go. All right, let's do another one. So 5, 8, 7. The same triangle, same picture. It says that little a is equal to 28.5 and little c is equal to 53.7. Find the angles A and B. And find little b. I'm going to find little b right now. And so that's super easy with Pythagorean theorem. Again, this is my hypotenuse. Just keep that in mind. I mean, here, look, I'll draw it again, I guess. That's fine. We got little a, little b, little c. Is that what they are? Nope. No, I mixed it up. This is why I don't draw. This is why I just say it's the hypotenuse. Let's move on. So I got 53.7 squared minus the 28.5 squared. Calculator, and I got a 45.5. Ooh, yuck. 513075. Awesome. Yeah, that's going to be close enough right there. Yuck. Okay, that's close. Okay, cool. Yay, we found it. So there's my B. How do I find my angles? Well, this is going to be angle A, and we have A and C is kind of, the things that we have there. I think using those two, sine, cosine, or tangent, I'm going to do a sine. So sine of A is going to be equal to my 28.5 over the 53.7. How do you find the angle? Is you do arc sine. And so this is that sine inverse stuff that we had just learned. You're trying to find the angle given the ratio. Calculator again, and I got 32.0545. And the last one, B, is super easy. The 180 rule, 180 minus my 90 from the C. That's that one right there, by the way. Minus the 32.0545 that we just found is 57.9455, and again degrees, and that is my B. Again, there's other ways to do it, but I just chose that, and well, there you go. Awesome. Now, how was that applications? Well, I'm looking ahead, and now, now are the applications. So going forward, I see a lot of word problems. Now, I can't write up all the word problems. I'm just going to give you the summary. So here's the thing. You know the ID, okay? I don't know which question this is. Maybe it's 3, maybe it's number 5 on the homework, whatever. So you go to the homework, you see this ID number, and you can match it up. Cool, that's why I do that. But there's a lot of blah, blah, blah that goes on that you don't need. And so I'm trying to summarize that for you. If you want to know the blah, blah, go read it right now, pause, come back to my video, and then you can, know what to do, I suppose, okay? So here we go. North, east, and then I've got an angle. It's like something with an A there, and they say 73 degrees. And they say it's something to do with bearing, which is actually very important in this particular case. And, yeah, this is a confusing problem. So a blank, and then they have a blank degrees, and then they have another blank, okay? Good luck. So, yeah, I know. So let's talk about bearing for a second. It starts at north, okay? And then it goes clockwise, mostly. I said normally. I said clockwise normally, okay? And so things are not exactly like this. I'm just going to show you this one in particular. I want to get to this angle. I start from north. I go this way. Golly, I wonder what degrees this is. Yeah, you're right. It's 90 minus the 73 is 17. Very good. So 17 degrees goes right there. But this is where the bearing kind of stuff comes into play. You started at north and you went east. Didn't I go this way? From north, going east, 17 degrees. Okay? Let me do another practice. This says in my notes to do more practice. So let's do another one. Let's say I have down here, I'm just going to make up something here. Let's say that is 280 degrees. That's a pretty good one. Okay, so what I'm actually going to do this time is start right here at south and move towards the east. How many degrees? Well, this was 270, right? And so then 280 is 10 degrees. So I'd say south, 10 degrees east. I know that's kind of weird that I didn't start at north and then I didn't go clockwise even, but I know there's all kind of different variations of this problem. When they say bearing, I just think north clockwise, like a clock, okay? But in this particular case, they're wanting north and east and blah, blah. Okay, it's fine. So here's another one over here. Let's do 200 degrees. That's a good one. So to get there, I actually start from the south, and I'm going to go west, okay? So again, I'm going from 270 down to 200. How many degrees in there? That would be 70 degrees. I started south, and I went west. So there's some other practice for you. And I don't know about this. Is this useful to you? Are you going to be the captain of a boat one day? Maybe you'll fly a plane. I don't know. Maybe you will be a captain of a boat. Maybe this will actually come in handy, and you'll never know it until that day you said, ah, I'm so happy Chad taught me bearing. Next question. So we got a coiled spring, and there's a lot of words that I have here. It's going to be pulled down 7 centimeters, then released. I'm thinking like a slinky now. And it says, write the equation for the distance traveled, t is seconds. And they even give you a little bit of extra stuff here. Amplitude is supposed to be a -7, and my period is 6 seconds, which, if you recall, is 2 pi over b for my period, right? And they say, write the equation. Let me just give you the answer. That's what I did on my notes here. Just give you the answer. D is equal to -7 cosine of pi over 3t. And there you go. We did it. Like, type the everything you see exactly as it is. You must have the d equals. Must have the d equals. Okay. So what the hey, man? What's going on? Well, down means negative. Negative. Okay. And it's pulled down from 7 and then released. So why are we using a cosine? I don't know. Okay, well, here's your spring. We're pulling it down. Oh, I know, because at t equals 0, we have some distance. So, okay, let me show you. Okay, so here's my spring at 0, and I'm going to pull it down to 7, okay? Negative because it went down. And then I release, and it goes so this is not exactly a good function for this. That's damped harmonics and blah, 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 but we're not going to talk about that right now. So cosine starts down low, so that's why it's going to, or high. It just starts at a number, and so that's why they're using cosine. Now, this guy right here came from my 2 pi over b. I simply just move these things around. You can see that the 2 and the 6 will make a pi over 3, so there you go. Whew. It's really not a hard problem. It's not. Don't let it get to you. Next question. We got 5, 8. That's probably the worst 8 ever. 21. So it says that d is equal to 8 cosine of pi over 2t. Okay, awesome. And they say simple harmonic motion. Yada, 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 yada. Okay, that's fine. Part A says, what's your max displacement? And the answer is 8. Yeah, it's right there. Now, technically, this is supposed to be the absolute value of the amplitude, or your amplitude is supposed to be your absolute value of what, I don't know. Absolute value, just in case, okay? Just in case somebody asks, hey, a negative? No, just the absolute value. Your frequency. Now, frequency, I don't think we've gotten a formula for this yet, so let me just go ahead and give it to you. I can't remember. It's 1 over your period, okay? So what happens is that this technically is just a flip, like the 2 pi over b. So now it's b over 2 pi. In our case, we have a b of pi over 2, and then there's 2 pi. The 2's do not cancel, but the pi's do. What happens is that the 2 down here mushes with this guy, the pi's cancel, and you actually get a 1/4, okay? So that's the frequency. Now, this is measured in hertz, which it doesn't hurt. But that is not really for this class. You just say the frequency is whatever. There's so much cool stuff going on here behind the scenes. But again, what we need to do right now is just get the problem done. So it says time for one cycle. And you know what they mean by that? They mean the period. Yeah, that's right. So the period is now 2 pi over b, but it's a flip of this guy. I'm going to flip it upside down. So now I'm going to get a 4 over 1. Of course, my math lab would be like yelling at you for that, so just put a 4 and we're good, okay? And so that's it for that problem. Moving on. 5, 8, 29. Now, this is a pretty cool problem. There's I can't remember if this was on the hilltop or there was a flag or something. I just can't remember, but I do remember this being really fun. So let's talk about fun math, right? So this is 48 degrees, and then this guy here is 21 degrees, and this x is my total height here, and I have 520 right here. Solve for x. I love solving for x. It's always fun. Okay, well, before we can solve for x, what I want to do is break this up into two separate triangles, okay? Now, the first one is the top guy. So we got a 48 right here, and I'm going to call this y, and this is a 520. To solve for y, what I do is I'm going to use tangent of 48 degrees is equal to y over x. Solve for y by moving it over. 520 tangent of 48. And I got, looking here, 577.5185. Yes, I see that. And then we got the bottom one here. And this one's at 21 degrees. All this is not to scale, of course. 520 right here. And let's call that a z. Solve for z. What are we going to use? A tangent. Very good. Tangent of 21 degrees is equal to z over the 520. Same thing. Move it around. Move this over. And I got a 199.60929. Oh, yeah. So then I got, this was my y, this was my z. How do I solve for x? Well, I just add them. Y plus z is equal to x. Add them together, and I got 777.12779. There you go. I just added those two together. Cool. Okay, I'm looking ahead real quick if you don't mind. I got another really cool problem like this, another one like this, a 1, 2, and then, it just looked like the same kind of problem. 3, 4, 5, 6 more problems left, but again, some of these are a little longer, some are like super fast. So this one's a little bit on the longer side. It's like the last one, and longer means, I don't know, 5 minutes rather than 2 minutes. So this triangle here is split up. It's like two separate triangles. I got a 24 degrees here, and then for the big one, I've got 29 degrees. I'm going to write it right all over it, so it's, you can tell like it's not just this top part, it's like the whole thing is 29. They want x right here, so that's an odd little thing, and they say that this full length here is 540. All right, so I can start with the thinner triangle, and so that's going to be the 24, okay? And I got 540, and let's call this a y value. So let's say that's y. And so again, I'm going to use tangent, and I'm going to just write it out so I know I'm not going to mess up, okay? I got y over the 540. Move that over, solve for y, and I've got... Yes, I'm clicking. I'm sorry if that's annoying. My bad. Because it's like, it's right in your ear. I'm clicking in your ear. Okay. So I got that little y, and that's fun. What I'm going to do is make the big triangle, and that's the 29 right now. I got 540, and then let's call that z. Again, z is going to be this entire distance here. can you tell how we're going to get x? Is we're going to subtract. So same formula here. Tangent 29 is equal to z over the 540. Move it over. I got a z of 299.3268887. So now my x is going to be a z minus y. And I just subtract these two, and I got a 58.903397, round to whatever they say. Cool. Next problem. I mean, there's not much to talk about. It's just, yay, we did it. Moving on. So I've got, yeah, that'll be fine. Got two triangles again. On the inside here, we got a 66. And way over here, we got a 34. And they say that this is the x that they want. And then this is the 370. And you know, honestly, I feel like I've already done this twice. Why am I even doing it a third time? I know, I might be a bad teacher at this point. I don't really know. Maybe I should just skip it. I mean, it's the same formula. Same formula. Okay, let's just do it. Let's just do it because that's what we do around here, right? So let's do this one. That's what we do around here. Yay, we're doing math problems together. So 66, and I got 370, and then I got, I don't know, let's make a y. Let's say that's a y right there. And so what do I use? I'm going to use tangent. But this time it's the 370 over the y. So I move both of them around, and I got a y that's equal to, just getting an answer here if that's okay, I got a 164.7346. Okay. And then I want to do the big triangle. And so the big triangle is a 34. And this is a z, so again, z is like the whole distance there. And then I got my 370. Same as last time. Tangent of 34 is equal to 370 over z. Solve for z, move them both around this time. And so z is equal to 548.5477755555575575. Okay, anyways. And then, hey, how do I find x? I'm going to subtract them. Exactly. Z minus y. Blah, 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 blah. 388.8129. Okay, it's good enough. Cool. Next problem. 4 left. So I got 5, 8, 39. I have a d displacement distance. I don't know, -5 sine of pi t plus pi, and they want all kind of stuff. And so first off, before we do any other math, what I want to do is factor out a pi because, well, otherwise it's going to be really nasty. Oh, whoa, whoa, whoa. Look, that looked like an S. And so I took it as an S. That was very bad of me. Bad, Chad. And so plus pi. Okay, good enough. So, no, not plus pi. Oh, man, I'm losing it. It's a 1 now, right? When I factor out, it's a 1 pi. Okay. So let's do some math here. Part A says max displacement. It's the absolute value, so you already got it. It's a 5. Very good. Absolute value. Frequency is b over 2 pi. So that's going to be that pi. That's my b right there, by the way. B, by the way. The pi's cancel and leave a 1/2. My period is the flip of this guy. So it's 2 over 1, just 2. Phase shift We haven't had this one yet, so I want to stop and talk about it. Very simple. It's -1. It's actually from right here. So notice again, the form that we should have is actually a minus sign between them, inside opposites. And so they're saying like solve for x, what would you get? It's a -1. It's a horizontal shift, and where are we going? Plus is actually to the left side. Again, inside opposites, left side, negative land. Okay, last one is E. We're going to graph it. And I'm just going to, I don't know, graph it if that's okay. This is a sign. It's negative, but there's also this shift and this phase shift thingy. What happens is it turns up looking like this. It ends up looking more like this, where this is a 2, because that's, again, my period, and it goes up and down to 5 and -5. Now, why did it end up looking like this? My original should actually have a negative, and it does this. That's my -5 amplitude in the front kind of thing, so it starts down low. Well, it's been shifted to the left, okay, by like 1 whole pi or something. No, by 1, just one number 1, because like, that's a 2. So I'm moving this whole thing over, and so what it looks like there is it actually looks like right here, and then you do this. And so I was just graphing that part. Okay. Blah, blah, blah. 5, 8, 41. Okay, so this is the tallest tower. Let me draw a picture of this thing. Oh wow, that looks like a pyramid. We're not going that kind of style here. So these are one of those like I don't know, cell towers or something like that. Got a little weird at the top there. Okay, so you're on the ground way over here, and you're looking at this thing, and you're saying, that's huge. And we got 29.7 degrees looking up, and they want to know what's the height of this thing, height h, and we are exactly 1 mile away, 5280 feet. So how many feet in the air is this thing? Like, there's words for this, but I just drew a picture because that's what we do here. So sine, cosine, or tangent, which one? Tangent! You're right! Gosh, you're just right every single time. Good job. Okay, opposite over adjacent. Multiply, move it over. 5280. Tangent of 29.7 degrees, and I got 3011.6588. I'm telling you, that's a feat. That's pretty high, okay? That's over half a mile high, okay? Woo! Anyways, 2 more problems. They're actually pretty simple. The last one's very simple. 5, 8, 51. So there's a boat dock. I'm going to make little planks on my boat dock there. And a boat sails. Let me just do a boat. Oh, yeah. That's such an awesome boat. It sails at bearing from north 58 degrees east. Blah, blah, blah. And it traveled 175 miles. So what is its y distance? Okay. Well, I'm going to draw the triangle with the knowns, the known numbers that we have. And so this is a 175, and they're looking for the y value, looking for the height. I know you're automatically thinking like a triangle right there, but that's not really what's going on. It's this guy right here, okay? But at y value still is this amount, okay? Blah, blah, blah. There you go. Okay. So, cool. We got this. So what would I use for this one? Be careful. Be careful. This is actually going to be a cosine of all things. Adjacent and hypotenuse. So 58 degrees. And then I've got my y, which is what they're looking for, and then the 175. Move that over. Solve for y, calculator, and I got 92.7358 miles. Everything's in miles. Last problem. We've come so far together. It's been such a good journey. Thank you. Thank you for hanging out with me. All right, -5. E to the -0.09x, and then I have a cosine of pi x. And to me, it just says graph it, and then how many oscillations do we have? That kind of thing. This is called damped harmonics. I'm going to go ahead and write that up because it is actually important. Damped harmonics. This part right here is the dampening part, and the harmonics is that part essentially. So without the dampening, without it, so this is just plain cosine, it'll keep going forever and ever and ever and ever and ever, okay? But when we dampen it, what happens is it goes brr, 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 and it just kind of peters out. Now, this is the reality of things. We don't have a lot of simple harmonic motion going on ever, but we do have the damped variety very often. Here's a great example. Let's say that we take a basketball and we like drop it on the ground. Boom, 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 boom. And it just kind of rolls a little bit. There you go. That's damped harmonics right there. You take a pendulum and you're going to, well, that's not a good place for a pendulum. You take a pendulum and you swing it and it's like this. And it goes tick, tock, tick, tock, tick, tock, tick, tock. And then it just kind of like hangs there eventually. So damped harmonics, very important. And I just kept scrolling. So what is the graph of this one going to look like? Well, graph it in the graphing calculator, like graphing with Desmos graphing. And because I don't know how you're supposed to do it otherwise. And what you get is something that goes like wampo, 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 wampo. Okay. Now they're saying how many oscillations are in this graph. And again, I am leaving out a ton of information. You have got to look at it, and it'll make more sense when you read it. Okay. So how many oscillations do we have? You're looking for like how many high points, essentially, how many like humps that you've had. And the answer is going to be a 4. That's it. There's nothing else to talk about there. We're done with it. So that's all I got. Thank you very much and have a great day.